Hi class, welcome to Math is Fundamental. Today we're going to be talking about isosceles and equilateral triangles. So first vocab term is an isosceles triangle, which states that an isosceles triangle is a triangle that has two congruent sides, which we call legs. So we've got one triangle with two sides that have to be congruent. We call those the legs. So this is going to be a leg, this is going to be a leg. Now, a little bit more vocab here, I'm going to kind of embed it into this definition, is that this side, the non-congruent side, is what we call the base. And we have to be careful because the base is not always on the bottom of the triangle. It simply means the side that's not congruent to the other two. All right, so we have that. We also have what we call, and I'm going to put it up here, the vertex angle. So the vertex angle is right there. And then we have these two angles here, which are what we call base angles. And this one is a base angle. So lots of different pieces of an isosceles triangle that we want to be familiar with the vocabulary of it. All right, so let's take that definition and build a theorem out of it. So our isosceles triangle theorem states that if two legs of a triangle are congruent, so if we have two legs of a triangle that are congruent, so it's an isosceles triangle, then the angles opposite those sides are also going to be congruent. So if this is true, then I know that the angles opposite those sides are going to be congruent. So let me draw it like this. Here's the two legs I have. This theorem tells me that these two angles across from those legs are going to be congruent. Notice it's not including that vertex angle. Those are simply the base angles. This is a base angle here and here. So that's what we call base angles because, well, they're the angles on the base of our triangle, which is that non-congruent side. All right, next we have the converse of the isosceles triangle theorem. Remember what a converse does from our previous lessons? A converse just flips our statement around. So now we have if two angles of a triangle are congruent. So if I start with two congruent angles in a triangle, then the legs or the sides opposite those angles are going to be congruent. So if I have our two congruent angles, then I can say that the sides across from those angles are also going to be congruent. All right. Next, we have equilateral and equiangular triangles. So an equilateral triangle is when all sides are congruent. You can kind of think of it as equilateral. So equal means congruent and lateral means the side lengths. All right, so equilateral means all three sides have to be congruent. Equiangular, again, the equi stands for equal and then angular for angles. So here we have all three angles have to be congruent. That's what we call an equiangular triangle. All right, and then here we have a corollary, which is kind of like a rule. It's another rule. This one doesn't have a name, unfortunately. But what it says is that if a triangle is equilateral, then it also has to be equiangular. My E got a little messed up there. Let me fix it. Equiangular. So this is going to be my if side. If we have an equilateral triangle, then I know all the angles also have to be congruent. Always, always. It always happens that way. And we can flip this and do the converse. If a triangle is equiangular, then it is also equilateral. So if all the angles are equal, then I know that all of the sides also have to be congruent. All right, so those are our terms. Let's look at just a few examples. No proofs for today. All right, so let's see. Example, oops. Sorry, dropped my pen. Example A, we have solved for the given variables. So if we look at our diagram, our triangle, we have two congruent sides of our triangle. So it's an isosceles triangle. And if we use the Isosceles Triangle Theorem, we know that the angles across from those congruent sides have to be congruent to each other. So I know that these two angles have to be congruent, and I can use that to make my equation. So I'm going to have 2x plus 5 equals 35, and then I can solve for x. So let's see, we subtract the 5, 2x is 30, so x is 15. And there's our first example. All right, similarly, we have B, we have our two congruent sides, which means the two angles across from those sides are congruent. Now this one's a little different because I know that this angle is congruent to that one, but that's not the information we're given. We're given 2x plus 5 and 100 as our vertex angle. So I'm going to use my Isosceles Triangle Theorem again, but I have to do a little bit of extra work. I need to use that 2x plus 5 a second time for that congruent angle. So I'm going to have 2x plus 5 plus 2x plus 5 plus 100. If I take all three angles in a triangle and I add them together, I get 180 degrees. So this, we're using the Isosceles Triangle Theorem, but we're also using the Triangle Sum Theorem as well. So we're using two different theorems here. All right, and then we solve. So we have, let's see, that's going to be 4x plus 110 equals 180. And then we've got 4x equals, let's see, subtract my 110, and I end up with 70 degrees. So divide by 4, and x is going to be, oh, it doesn't look like it's going to be a whole number, but that's okay. 1 minus 4, we have 30, 7, 28, and 2. So we end up with 17.5. And sometimes we have decimals, and that's just fine. It doesn't have to be a whole number in order to work out. All right, and then our last example today is this triangle here. We're given these three lines, which means it's an equilateral triangle. So equilateral, and we're trying to solve x, which is an angle, which means we know that equilateral implies that it's equiangular. So I know by that corollary that all three angles have to be congruent. Now there's two ways to do this problem. I'm going to show you the long way first, and then I'll show you a little shortcut. So here, if that's x plus 10, I know this is also x plus 10, and so is this one. And I can use my triangle sum theorem. So x plus 10 plus x plus 10 plus x plus 10 equals 180. And then solve for x. 3x plus 30 equals 180. 3x equals 150, so x is 50. So it didn't take too long, but there is a shortcut. If I know in a triangle that all three angles have to add up to 180 degrees, and if I know that all three of those angles have to be equal, then each angle has to be 180 divided by 3. It has to be a third of 180, which is 60 degrees. So if we know that we have an equilateral triangle, I can simply set one of my angles, like x plus 10, equal to 60 and solve for that. It's a little bit faster, a little bit less work. We get the same answer, but it does involve that other little bit of knowledge that each angle in an equilateral triangle is, in fact, 60 degrees. All right, and that concludes our lesson for today. Thank you so much for watching, and remember, math is fundamental.